Black holes, the universe's most mysterious objects. We talk about black holes like monsters, devouring anything that wanders too close. The real thing is even stranger. Despite the name, a black hole isn't a hole at all. It's an object, a place where an enormous amount of mass is packed into an incredibly small space. When a massive star collapses under its own gravity, the core can become so dense that space-time itself caves inward. What's left is a black hole. Not an opening, but a boundary, a region where gravity becomes extreme. If the sun were compressed into a black hole, it wouldn't suddenly start pulling everything in. Earth would continue orbiting as usual. What makes a black hole dangerous isn't just its existence, it's how massive it is, and how close you get to it. Everyone knows the famous line, "Not even light can escape." And it's true. Once something crosses the event horizon, it's gone forever. At least according to classical physics. At the smallest scales, quantum physics suggests black holes can slowly evaporate through Hawking radiation, a process so weak that even the largest black holes would survive far longer than the age of the universe. But here's the twist. Black holes don't just swallow matter. They also create some of the most violent, brilliant eruptions in the universe. Jets of plasma, particles accelerated to near the speed of light, can stretch across entire galaxies, and they're not powered by the black hole itself, but by the chaos spiraling around it. Matter heating to trillions of degrees. Magnetic fields snapping like cosmic whips. Rotation twisting everything into a hurricane of fire and gravity. This is the edge of physics, the event horizon, where the known laws of the universe begin to break down. A black hole can be silent or explosive. It can hide in darkness or shine brighter than a trillion suns. In 2018, astronomers observed an unusual cosmic flash called the Cow. It was brighter than most supernovae and unlike anything seen before. One leading idea is a black hole ripping apart a star. Take a look at one possible scenario. But here's something even stranger. You can see both the near side and the far side of a black hole at the same time, because gravity bends light around it like a lens, wrapping the universe onto itself. Look closely at a real simulation and you'll notice a ring, a perfect circle of trapped light. That's the photon ring, a place where light orbits the black hole before deciding which way to escape. Now, before we go any deeper, a quick tour of the different kinds of black holes. Primordial black holes, hypothetical tiny black holes formed in the first instant after the Big Bang. Some could be microscopic, others could be asteroid-sized. If they exist, they may be everywhere. Intermediate black holes, rare and mysterious, too big to be from a single star, too small to be supermassive. They may form from runaway collisions in star clusters. Stellar mass black holes, born from collapsing stars. These are the most common, a few times the mass of the Sun. Supermassive black holes, monsters millions or billions of times the mass of the Sun, sitting at the center of galaxies, including ours. Their gravity shapes entire star systems. Now that you know the cast, let's talk scale, because this is where black holes stop being objects and start becoming impossible. Here is our Sun, a giant containing 99.8% of all the mass in our solar system. But compared to black holes, it's barely a spark. Some black holes would fit inside a city. Others could swallow our entire solar system whole. And then there's Ton 618, a cosmic titan so large its event horizon would stretch past every planet, past Pluto, past the Kuiper belt, deep into the Oort cloud. One of the largest things ever discovered, bending space across entire star systems. How do we find these things if they're invisible? We look for their fingerprints. A star orbiting an empty, invisible point. There's a clue. Gas heating to millions of degrees, another. Or the universe itself shaking. That's two black holes colliding in the dark, sending out gravitational waves we can feel across space and time. Some black holes spin, and some spin so fast they drag space-time with them like a cosmic whirlpool. These are Kerr black holes. If you could orbit one, time would slow almost to a stop. Minutes for you, years for the universe outside. You may remember this from the movie Interstellar. The crew visits a planet near the spinning black hole Gargantua, where 1 hour on the surface equals 7 years for those far away. The filmmakers consulted real physicist Kip Thorne to make the time dilation scientifically accurate, a dramatic illustration of the extreme effects of Kerr black holes. And here's a mind-bender. A rotating black hole contains extractable energy. In theory, it could power civilizations, a natural engine built into space-time itself. These aren't just theories. These are real black holes. Cygnus X1, Sagittarius, a star in the heart of our galaxy. Each one bending time, space, and light. Each one unique. Each one rewriting the rules of reality. We live in a universe filled with wonders. But black holes stand apart. Not because they're the most dangerous, but because they are the most mysterious. And every time we look closer, the universe becomes stranger. Thanks for watching. If you enjoyed this journey into the impossible, join me for the next one. Hit subscribe and let's explore the next topic together.